Hello everybody. This video is going to show us how to plot the homework data assignment in Excel. What follows will also be a Python video after this one, which will be uploaded to Blackboard, showing you how to do the same thing in Python. So let's get started. Our data file, if you go to Blackboard and go to your data folder and right click and save it as, and then you open it on your desktop, will look something like this. Here I opened it up in Notepad, so you can actually right-click the file and open it in Notepad to actually get a view of it here in Notepad. Let's take a look at our formatting here. So this is a typical file. This is something that you'll generally see in the industry or in research off of instruments or whatnot. And it's usually separated into your data headers up here at the top, and then your data, which follows down here at the bottom. Now, this is from our weather tower on campus at Texas A&M University Corpus Christi, and this is a one-day file. So this is for 2019, April 25th. And what you'll see is the data is separated by every 2 seconds here. So we're sampling at half a hertz. So every 2 seconds is when we're getting a sample of what the current weather conditions are. And that means that this file is gigantic as far as how many rows it has. And this is going to put your PC to a test, or your MacBook to a test, because whenever you bring this into Excel, it's using a considerable amount of resources to do the plotting. And this is where Excel has a hard time with it, and something like Python is amazing at handling this kind of stuff. So let's take a look at what all of these rows mean. We have 4 headers here at the top. The very first header, this first row up here, is just giving us some information on the data logger itself. Now, the data logger inside of our weather tower is sort of the brain. All the instruments are connected to it, and this is just showing me what program's running on the data logger, what the data logger actually is, etc., etc. Generally, this is not a row that we need to worry about. So whenever we're importing data into Excel or Python, we don't really care too much about this row. We do care about the next row, though. The next row here is telling us all the variable names that are inside of our file. We have timestamp, we have record number, we have wind speed in miles per hour, we have wind direction, we have solar flux in kilowatts, we have rain inches total, we have air temperature in Fahrenheit, relative humidity, the enclosure relative humidity, so it's the relative humidity inside the control box itself. It makes sure that we're not hitting saturation inside the control box. That would be really bad because then we'd get condensation on the inside. And our barometric pressure in millibars. This is a very important row. And whenever we're plotting, we're going to pull from that row. We're going to make sure that that row is actually getting imported. The next row here is giving us our units. And while important, this is not necessarily one that we have to import whenever we're making our plots. But it is a good reference point, because if you're working with temperature data in your future career, are you dealing with Fahrenheit? Are you dealing with Celsius? Are you dealing with Kelvin, Rankine? Well, you can go back to the data file here and see what the column information is. And here we can see that our temperature data is in degrees Fahrenheit. Same thing for pressure. There's lots of pressure measurements, but here we're working in millibars. There's lots of solar flux measurements. Here we're working in kilowatts per meter squared. So this is a good reference point. The final row here is just showing us our sample rate. For the majority of these variables here, every 2 seconds it just takes a snapshot of what the variable actually is at that point. We're not doing any fancy averaging or running averages or anything like that. It's just taking a measurement every 2 seconds. The only difference here is the rain inches total. This value here is going to be the total amount of tips for the rain gauge every 2 seconds. So if we have a tremendous amount of precipitation coming down, like a torrential rainstorm, that could actually trip multiple times in 2 seconds. So that's what's giving us our total measurement here, and that's why we use total here. Now this is a standard CSV formatted file. You can see that each one of our columns down here, here's timestamp, this is our time, here's our record number, here is our wind speed in miles per hour. Each one of our variables here, each one of our columns is separated by a comma, hence CSV, stands for comma separated format. Now this file here is a .dat file, .data file, but still it's in CSV format. So how are we going to work with something like this? Well, we're going to open up Excel and we are going to make a new workbook. Now versions of Excel vary. They vary a lot. You can have an older version of Excel, you can have a newer version of Excel. It's assumed that if you're using this as a university student, they make Excel and a bunch of all of the Microsoft products free to you as a student that you can download through the computing resources. So it's assumed that you're going to be using a newer version of Excel like this one here. If you're having an older version of Excel, things still hold true for the majority. They haven't changed too much. But if you're having any issues, please let me know. I'm more than happy to work with you and make sure that things are getting done properly. Because I know it can be a little bit frustrating, and I'm more than happy to help you out. So what we're going to do up here is we're going to go to File at the top left, and we're going to go to Open. Now, wherever you downloaded that file from Blackboard, the 2019-0425, you'll need to find it. So you might have to hit Browse down here at the bottom left, and then go through your computer here and actually find where you stored that file. If you stored it to your desktop or whatnot, that makes it pretty easy. For me, I've already opened it today, so it's right here at the top. I'm going to left click to open it up. And Excel's going to notice, hey, it's a formatted file. It's not just a text file. There's lots of formatting in there. So what do you want to do with it? Well, we want to keep delimited checked right here at the top. So characters such as commas or tabs separate each field. That describes our file perfectly. So we're going to leave it as delimited. We're going to go to Next. This next window here is saying, well, how is your file delimited? Generally, we can go ahead and keep tab. Tab is a good one to keep clicked as our delimiter. But what was our file separated as? It was separated as comma. So we need to keep comma selected here. And then we'll hit Next and just leave it as general up here for our data format. And we're going to finish up. Perfect. Now each one of our data points, each one of our variables is separated into an individual cell. Now your time over here looks weird. It's a bunch of number signs. What does that mean? It means there's too many characters for the size of your column here. So all you have to do is make this column a little bit bigger. And it'll be perfect. Great. So what's the goal of this assignment? The goal of this assignment was to plot temperature and relative humidity for the entire 24 hours. So what variables are we going to need? We're going to need temperature, obviously. Temperature is right here. We can see air temperature, degrees Fahrenheit, and then here's all the data underneath it. So we're going to need column G. We're also going to need relative humidity, and that's column H. You can see relative humidity right here, and then percentage. So these are our two data columns. But we're also going to need our time column. We're going to need our timestamps over here because we need an X variable. Our X variable is going to be time, and then we're going to have two Y variables, temperature and Fahrenheit. So how do we select all of these so we can begin to make a plot? Well, what you want to do is you want to hold Control, and click A up here. You want to click the column. Oh, hold on. Let me get rid of that. You want to hold Control and click A, or just select A. Just select A. Now hold Control and select G. And then keep Control clicked and then select H. So what you should end up with here, because I made a little mistake there in the beginning, you should only end up with the entire column of A selected, the entire column of G selected, and the entire column of H selected. Great. Now we need to get rid of our headers that we don't care about. And there are 9 cells up here that we need to remove. So how you do that is you keep Control selected, and we're going to remove these top 3 up here. So click them, one after the other, and we'll see that they get deselected. We want to keep the second row there. We want to keep timestamp, we want to keep air temperature Fahrenheit, we want to keep relative humidity. So go ahead and select the next 6. Keeping Control selected, we're going to click these and subtract them from our columns. So what you should end up with is gray, or that grayish color, covering timestamp and then all the timestamp data, and then covering air temperature and then all the air temperature data. Since we somewhat have relative humidity here selected, that's why it has the green border, but it is essentially gray behind that, and then all of our relative humidity data behind that. Perfect. Now we want to make our plot. So we're going to go up here to Insert at the top. We're going to come over here to our Chart Options here in the middle, and we're going to select a scatter plot. And there's lots of scatter plots that you can do. I prefer these scatter with straight lines and markers, so we'll go ahead and put that one and select it. And our chart is going to eventually pop up. Now, quick note, the PC that I'm doing this on is my personal PC. It's a gaming PC, so it's pretty robust, and it even struggles to handle this amount of data in Excel. Excel is just not a good resource for making plots like this. And over the course of your careers as atmospheric scientists or environmental scientists or geologists, you're going to be working with much more data than just a day file. You might be working with an entire year's worth of data or multiple years worth of data. And the stations could be more than just one simple weather tower. It could be weather towers across the entire United States. So this is a really big selling point for using Python or a data language like Python instead of using Excel. Excel, to make a pun, excels at small macros, small spreadsheets like business spreadsheets and whatnot, where it's not as computational or data heavy as what we use here in data science. So our chart here, we can grab and we can drag and we can move it around. We need to make it bigger. So we're going to, down here at the bottom right, we're going to left click and drag this down to make it bigger. And you might have noticed that our timestamp stuff down here at the bottom were all jumbled together, and that's because our chart was too tiny. But whenever we make it bigger, we see that we make that nice and pretty down here at the bottom. And we have our air temperature in blue, and we have our relative humidity here in orange. Great. So we need to make some changes to this chart to make it presentable. You always have to have a title, so we're going to click up here on the title, and then we're going to change this to exactly what it needs to be. Temperature versus relative humidity. And we should put the day in here too. So we'll do 04/25/2019. That way we know what day this was. And we're going to left click to save just on the chart, anywhere on the chart. Works out. Now, what you're going to see every time we make a save is it takes a little while for that save to go through. It takes a little while. So, what else do we need to change here? We need to change our x-axis. We need to add a label down here so we know what this actually is. So up here at the top left, we're going to add chart element. And we're going to go to axis titles. And then we're going to come over here to primary horizontal. And we're going to click it. And it might take a little bit for it to pop up with a little text box down here that we can change. There we go. So we'll make our changes here. We're going to call this time. Actually, we're going to call it local time. And CST. Local time CST. And we're going to click the chart just to make sure it saves. And give it a second. You might have to give it more seconds if you're using a laptop. Highly recommend using maybe one of the computers at the computing center or in the library to do stuff like this. Great. Now we need to add a y-axis here too. But we have a problem. We have two different plots here. We have temperature in blue and relative humidity in orange. Temperature is going to be in degrees Fahrenheit and relative humidity is going to be in a percentage. They're two different units. So if we're going to do this properly, we need to have two different axes. We need to add a secondary y-axis over here on the right-hand side. So how do we do that? Well, the one we want to move over to the right-hand side is going to be relative humidity. So anywhere along the orange line here, go ahead and just right-click and then go to Format Data Series. Over here on the right-hand side, what should pop up is an option to select either primary axis or secondary axis. Go ahead and just select secondary axis. And it might take a minute for it to update itself. I always hear my CPU ramp up a little bit when I make changes to the graph here. Good. All changed. Now we can close out of this. Look at this. We have a secondary y-axis over here on the right-hand side. Perfect. So let's add a label for that. Let's add a label for that. That's our secondary y-axis. So we're going to go back over here to the top left and hit Add Chart Element. Axis titles. And we're going to add a secondary vertical axis label. There we go. And what are we going to call this one? This one's going to be relative humidity percentage. Relative humidity percentage. Give it a minute to update. All right, now we need to add a primary y-axis over here on the left-hand side. So we're going to go back over here to Add Chart Element, Axis Titles, and Primary Vertical. Axis Title, and we're going to change this to temperature in Fahrenheit. Our chart is looking fantastic. It's looking fantastic. The one issue I have with this is all of this white space that's not being used for anything down here. All this white space. We're not able to see all the variation here in temperatures because we've smushed the temperature up here to the very top. So let's get rid of that. Let's change our lower bounds. For our right axis here, for relative humidity, we'll see that our relative humidity actually stays above 40 the entire time. So we'll make that our lower bound. So left click the y-axis over here, and then right click it and go to Format Axis. And we're going to change our minimum bounds here to 40. And then hit Enter. And it'll take a little bit to update. Perfect. Look at that. That looks great. We're going to do the same thing over here with the temperature axis, the primary axis up here. And what we can see is it never really goes below, well, it shouldn't say it never goes below 60. So that's a good lower bound here. So we'll select this axis, right click, go to Format Axis, and then set our minimum to 60. And then hit Enter. And then let it update. Fantastic. And what's the goal of the assignment? The goal of the assignment is to look at the relationship between temperature and relative humidity, which we talked ad nauseum this week during lab. So with this, you should be able to make your comparisons. How do we save this? Well, one way you can go ahead and save this, or if you want to post it into your Word document that you're working on for your homework, you can right-click on the chart and go to Copy, and that will let you copy that chart into your Word document. Another way you can do this, especially if you're on PC, now Mac has its own ways to screenshot. There's some commands. You can go ahead and Google them. I'm not a Mac person, but I know it's very easy. It's just like a Windows key G or something like that. It's very, very simple. But for Windows, what you come down here and do is in your search bar, you type snip. And you're going to use the snipping tool. So snip, snipping tool. I'm going to move this over here to the left. You click New. And then you just drag out a square over the plot that you want to save. And now you have this. You have a nice little plot here. And you can click Save up here. And you can save it anywhere that you want. And then you can drag it into your Word document. So that's the other way to go about it. Excellent. That'll do for this little tutorial on doing two different data variables on one plot and doing two different axes. Y'all have a great weekend.